Hey guys, Jay from RS Garage. Today I'm going to take apart this Billet 2JZ. This belongs to the guys out in Texas at Smileyautowerks. They work on a lot of Mark IV Supras, and this engine is out of their flagship white Mark IV Supra that has a 6R80, 4R80 trans that Motec USA has been working to control and run in conjunction with the Motec. The engine kicked the rod out of it, and we had been talking back in Texas. I said, hey, it's time to put rods in it, and they said, oh, you know, one more event, and with around 300 passes on the car, a rod removed itself from the party, damaged the block, as you can see with the comical band-aids that were applied. Maybe there's a large maxi pad on the hole that's probably in the oil pan. I didn't get that, but got a big window in the block. So we got to take this engine apart, see what's salvageable, and move forward. This is not a manufacturing problem, it's a fatigue problem. And most people that have run aluminum rods for a period of time say that, depending on the power level, 150 runs, 200 runs, take the rods out, throw them in the garbage, put a new set in, and found out the hard way on this one. So get it apart, see what's salvageable, move forward from there. The camshafts are Brian Crower 276s on a non-coated bucket. And as you look down the lobes, you can see that things are looking pretty good, especially for an engine that goes over 9,000 RPM on a regular basis. While it looks like there's some action on the nose of the crank, for the most part, it's just the assembly grease, whatever they use to put the balancer on. The snout of the crank looks pretty clean for the amount of use the engine has. There's some small chatter in a couple spots, but overall looks pretty good for the amount of run. Now this is a cool little something that JTO and I have been working on. It's a wrench for taking the cams out of your JZ or putting the cams in your JZ. And it's GSC on one side and BC, Kelford, HKS, everybody else on the other side. And it's pocketed to where it can kind of lay in the casting, to where when you are installing or removing the camshaft sprockets, you can hold the cam in place and not have any drama, which on the cast cams, it's not really much of an issue, but on the GSC cams, for those of you that use that product, it's not a wrench size. It's time to go get an adjustable wrench. So this is a pretty cool way to have that tool available for easy access. And I did a limited run of them. I don't know if I'll do a second run, but at a minimum, some of the dudes that are in the space that work on JZs all the time, they can find their way into their toolbox and just be useful. So in the past, we've taken apart JZs and we've seen on the higher horsepower cars, the cam drive pin start to dig into the cam sprocket. It's worth noting that these things look pretty clean, so there's no real funny business going on there. There's a very small amount of marking from the cam dowel pin into the cam sprocket.
Poppin'.
Taking the cams out, you can see that you have the buckets kind of standing up out of their bores, and then these two are kind of stuck down in the bore, which means these valves are definitely bent. So the valves effectively got shorter. When the piston hit them, they folded over, and that's why you have these buckets that are sitting down in the head versus standing up out of the bores. The head's not loose. If you take a look at the oil that is laying around in the head, you can see it's pretty clean, and that's a big deal when it comes to keeping your valve train alive, because you have this flat tappet operation, and as the oil breaks down from fuel contamination or lack of maintenance, you're going to have more bucket related problems than you would if you really stayed up on the oil changes. So food for thought, you're looking at an engine that has quite a bit of runtime. It's a 7-second car and the valve train looks pretty nice. So something to consider when you're forming a complaint or trying to analyze a problem with valve train stability or valve train longevity. It's like, well, how are you treating the engine, especially you guys that are drifting these things or are heavy on two-step. It's not a bad idea to pull the cam covers off and check lash and look at the valve train, because what we do with these engines is quite a bit different than what Toyota designed it for. So we're hard on stuff. So it's okay that we're hard on stuff. We're having a lot of fun in the process, but a little bit of maintenance goes a long way. So looking at valve lash, making sure that you're not beating the valves out of it or reshaping the valves through excessive heat, and making sure that you're not wiping buckets out from poor lubrication or excessive amounts of poorly timed two-step action. Since this engine was assembled, it's used a fire ring style gasket. And if we clean off some of the oil and the glue used to seal it on a couple cylinders, we can see just how much that ring kind of burrows its way into the cylinder head over time. And interestingly enough, if you look right here, we've got a pretty pronounced lip. See that lip on this side? So this is the exhaust side of the head where the casting is going to be subjected to more heat. And then if you come over to the intake side of the head, a whole lot less action with that ring bedding into the head. And you can see it also in the kind of a signature. This is not, this dark ring is not oil, it's vibration. So you have this ring that's vibrating very small amounts. The head's vibrating very small amounts, but it rubs itself together over time. And if you look, the signature of the rub on the exhaust side of the casting and on the intake side of the casting is quite a bit different, because this side of the head is hot. You have all that heat, there's more expansion, and it's bedding in more. So this is one of the things we talked about with the fire ring head gasket and the flame hoop head gasket. Things are going to be moving. There's no way around it. And Smiley has been maintaining this gasket system by watching the coolant pressure, and anytime he sees an elevated coolant pressure, he goes back in and he retorques the head. And that's worked extremely well for him, because again, you have this ring is not really in a position to deteriorate. If you don't lean this engine out and torch a hole in it, it's a long-term situation. However, it does come at the cost of bedding into the casting. And as we move forward and we start to talk about valve train life and how the shape of the valve job and the shape of the valve seats changes with heat and changes with deflection, keep in mind that when you have a high level of influence at the deck for distortion, when you're forcing solid objects together, you're going to be distorting these valve seats, which in turn is going to change your valve job, and the valve exhausts a lot of its heat back into the seat through the valve job. So if you really want to zooming out on longevity, You want the least amount of distortion at the flange seal or head gasket surface to promote the longest amount of life out of the engine, not only from a sealing standpoint, but from a valve train standpoint. Now you can also see there's sealant on this head gasket. Copper gasket, it's a race style gasket, and through that you have to use some kind of sealant to keep the oil and water from leaking out of it. It's not a passenger car gasket, it's race car stuff. So there's a lot of glue applied to this gasket, but as you can see, if you look down the sides of the block, it wasn't like it was leaking out a bunch, but it's one of the inconveniences of going to a copper gasket system. Now, another thing to think about as you move to a copper gasket is two things. If you see how the silicone is spooged in around the oil feed hole, when you put a gasket on using sealant, you want to be sure that you don't block that passage off, because if you put too much sealant in this passage that feeds the cylinder head gets plugged up with sealant, you'll starve the cylinder head and you'll ruin it very, very quickly. Second thing to note is the factory head gasket is the restrictor for the cylinder head. So you see this small hole here, and you see in the copper gasket you have a larger hole. So it's not uncommon with an engine with a copper head gasket to add a restrictor to the block itself. That way you don't flow too much oil to the head. Now, what is too much oil? Too much oil is that there's so much oil getting in the top of the engine it can't return down to the pan, and the oiling system is suffering because it effectively doesn't have enough oil. This car has a dry sump system, which is scavenging oil, so it's not as much of a risk. But if you have a copper gasket on a wet sump system, you have elevated crankcase pressures and a non-restricted head gasket because you're using a copper, something to think about. If you pump all that oil up into the engine and that crankcase pressure is coming up out of the bottom and the oil is trying to go down, and there's so much traffic that you can starve the bottom of the engine. So if you are using a copper gasket, two things: make sure that you don't put so much sealant on the gasket that it plugs off the oil supply to the head, and make sure that you don't present too much oil flow to the top end of the engine because it will starve the bottom end of the engine. A best case scenario, if you don't have a lot of time to R&D this situation, is just follow the orifice size in the factory head gasket, which is around 100 thousandths. If you haven't seen inside of a MazWorks Pro Street block, these may look a little foreign to you. This is a big step stud, so big coarse thread on the bottom going down on the block, lots of engagement, and then it necks down into a 1/2 inch stud to go up into the cylinder head. So it's a shelf part for some other applications that ARP services, but been repurposed for this particular engine here. Also, you can see that Mark has positioned the threads down under the deck to try to minimize distortion at the deck surface. I talk a lot about vibration, and if you're running an engine hard and you're shaking it, you're detonating it, you're rattling it, you're misfiring it, you'll get a lot of action on the nose of this sprocket, on the back of the sprocket, on the face of the balancer that butts up against the timing belt guard. You'll get action. And if you look in the balancer, there's some stuff going on. But if we wipe it out, it's really not that bad. And you can attribute that a lot to the ignition timing this engine sees. This engine is not run over timed. It's run with low to mid teens, so 13 to 15 degrees. It's air to air intercooler. It had race grade ethanol in it for the large part of its life. And then around last year, started mixing with more methanol because methanol is a better racing fuel. But the point is it's not being shook to death. So one of the things that we get to see as we go into the engine, we know that the number 6 rod is dead. Well, number 6 is a troublemaker on a JZ. And if we're lucky, we'll get to see if the housing bores are still in shape on the other rods. Because over time, what will happen is you'll start to close the big end of the rod up. That's why if you look at a aluminum rod instruction, it'll say minimum clearance of 3 thousandths, because you may run that rod for a period of time and it may actually close the big end of the rod up, and that will deduct from your vertical oil clearance. So if you put it together at 2 thou and then you close the rod up 1 thou, now you only got a thou of clearance. So don't be afraid of larger clearances with aluminum rods. And if you really want to blow your mind a little bit, measure a set of aluminum rods inside in your garage or in your workshop. If you got air conditioning, that's great too. Then just go set it out in the sun. And as it comes up to around 100 degrees, it'll change by a couple thousandths real fast. So there's a lot of forgiveness in that clearance range as long as you have too much and not enough. But it'll be interesting to see if any of these other rods have closed up during operation. Oh man. Apparently, when the piston is completely changed shape, the ring tension goes away a bit. Oh man. That's rough. Oof. Wow. It's this is an upside down smiley face. If you see the rings, so up here put your googly eyes, and there's your upside down smiley face, where the piston rammed itself into the cylinder head and changed shape. You can ruin the cylinder head when you do this, because you'll smash the casting and it will deform also. I'm curious to see if I can knock that pin out, see what kind of shape it's in. So with aluminum blocks, there's opportunity to repair. So if you damage a pan rail or you knock a hole in the side of it, sometimes you just fix them. This has crushed and removed the area from the main galleys that travel front to back on a 2JZ. So at some point, the time in repair versus the cost of replacement cross over, and it's not an exotic engine from the standpoint of, it's not a 250 GTO Ferrari block that costs 200 grand for a bare one. So you just throw this thing in the garbage, it goes over to China, comes back in beer cans, and you replace the engine block. But it is, because of that trauma at the bottom of the cylinder and through that oil galley, I think it's worth fixing. pretty common with aluminum rods. You can really keep a bearing nice over a lot of runtime and a lot of stress with an aluminum rod, because the aluminum rod is quite an absorber to all the vibration and harshness that's coming down from the top of the piston. Obviously, with the destruction on number 6 and the oil flowing down the crank, you've got a good amount of particulate in the number 7 main bearing. So this spotting isn't from normal use, it's from the aluminum particles that were caught up in the chaos passing into this journal. So bearings look really nice otherwise. Pretty amazing, that particulate. You know, the engine's blowing up and it's spinning down, and it's not going to be run again, but there's trash that works its way through the engine at a pretty fast rate. So in a situation like this, the tri-sump pump and the turbocharger are going back to their respective manufacturers to be serviced, because the trash that happens enters those devices too and contaminates them. So you really make a mess when something like this happens. As you look down the rod bearings and you look closely from 1 to 5, because 6 is no longer with us, you can see that each bearing has a little bit different of a wear pattern on it. 4 and 5 have the most amount of 12 o'clock action, whereas if you look at this one, see how it's a bit back from the top of the bearing shell? So you have some action here on the bearing, but then if you move to number 4, it's more centered in the top of the bearing. This is crank rotation, cylinder pressure, oil displacement, how each cylinder is running. There are 6 pistons on the same crankshaft, but they don't have equal amounts of cooling, equal amounts of airflow. There's 6 different engines working together is the safest way to look at it. And back in the day, you'd work on an engine like this and you would make adjustments. Once you got done burning up spark plugs, and then you got done burning up pistons, and then you got done hammering bearings out of it, you would then run the engine using a softer bearing, like a P bearing, and you'd pull the bearing out and you'd look at the bearing, and if the bearing was going flat, you knew that you had a bit too much timing in that cylinder, because with high volumes of methanol, you don't get that ring when it knocks. It's kind of a dead blow, and that dead blow will deliver itself into the bearing. So it wasn't uncommon in the old days when you had an 8-cylinder engine for not every cylinder to have the same compression ratio, because they didn't have a way to electronically control the timing, so they would use the mechanical compression ratio to soften up different cylinders. So we're very spoiled nowadays with the ability to tune engines, but this is just a neat illustration that while number 6 checked out of the party, the others look pretty good, but they're not the same. That crank looks really nice, aside from the wrecked part. So as I mentioned earlier, we may see the rods close up. So there we are, just over 1.5 thou of vertical oil clearance. And that is about 1 thou and a couple tenths smaller than it was when it went together. So the rod effectively shortens up in the vertical oil clearance. That's why it's important to set them to the minimum clearance. And then as you're running the engine, you take a look at it every now and then to see if the rods are keeping shape well. So when you look at the bearing, there are some fine scratches. If you see these are from the mic checking bearing clearance. Now there's a mark over here, which is, I would call it crank whip. And if we look at our number 7 cap, the other end of the crankshaft, we may have an opposing mark. And you can see, you kind of have to look through the debris, but you have a mark here too, right out here on this outside edge. So things are moving around a bit, and when they move around a bit past the bearing clearance and they displace the oil, things touch down. But overall, when you pull a bearing out of an engine and you look at it and the mic marks are still there, it's like doing pretty good. You know, this engine sees over 55 pounds of boost out of a 94 millimeter precision. I mean, it's raced. You know, it's not a light car, which really holds back its performance overall. But these dudes are having a lot of fun with this thing, and it's kind of gambled on taking it apart in time. So, looking at the crank, one of the things that kind of the old wise guys will tell you is if you lose a rod on a crank, you don't reuse the crank because the crank's seeing a lot of trauma. So we can check this crank for straight, but it's got some contact going on in this mess back in number 6. If you cleaned up some of this area here, this aluminum splatter and abrasion, it may look okay, but keep in mind that as this engine goes back into service, or the engine for the car goes back in service, you have to weigh the risk reward on reusing parts that have seen trauma. So these parts don't get better after they've had these bad events. So you could say, unfortunately, a lot of this stuff is throwaway stuff. The cylinder head's been hit with the piston pretty hard, and you could see the materials down around the valve seats because the piston just wackoed it. And then you've got some stuff going on here in the crank, and we can put it in the lathe and turn it and get an idea for how straight it is or how not straight it is. But this going on back here at this back crank weight, you know, you're talking about a lot of negative action, just beating things to death back here. So most of the time when you break a rod, the crank bearing face will suffer some pretty solid abrasion too. And if you take a look here, you have where the rod bolt was coming in contact and jamming up against this face of this part. So, you know, this is going in the garbage, this is going in the garbage, the rods are going in the garbage, the piston's going in the garbage, the head's probably going in the garbage. It's an expensive day. So I guess the lesson to be learned here is if you're using an aluminum rod, again, it's not a brand thing. I've used R&R for a number of years. The dude Mike, he's awesome to deal with, just a cool old school guy. But things have a service life, and when you're racing, you have to really respect that service life and keep reasonable notes. If something bad happens, if you have a lean out, or you know, the oil pump belt falls off and you're still going to keep running the event, like, take notes of that stuff. That way when it comes time to pull the engine apart to rebuild it because it needs to be rebuilt, or to work on it because it's failed, you can kind of go back through the life that the engine has experienced and hopefully learn something from it. Because in this case, Smiley can say, well, 300 runs was too many, and they can back it down. But, you know, really depends on your perspective on it. You could be a guy that says, that engine doesn't owe me anything, I had a lot of fun with it. Or you could be a guy that kicks rocks for 6 months because he lost an engine after using it a lot. You know, most guys don't get hundreds of runs out of an engine at this level of stress. So it all depends on how you look at it. But we're gonna throw a lot of stuff away on this one and see you next time.